A few years ago, a corporate executive walked into our clinic holding his health report. The diagnosis, printed in bold letters, said, "Pre-diabetic." He looked confused. "I run 10 kilometers every morning," he said. "I follow a disciplined diet. I avoid sugary drinks, so how can I be pre-diabetic?" Just a few days later, another patient arrived with a completely different story. He had fatigue, constant thirst, abdominal weight gain, and declining energy. Yet his blood sugar values were still considered normal. Two individuals, two very different metabolic realities, yet both were being evaluated using the same universal blood sugar standards. This raises an important question. Can a single glucose number truly define diabetes for every human body? This question becomes even more important when we look at India. India is often called the diabetic capital of the world. Millions of people are living with diabetes today, and millions more are classified as pre-diabetic. Yet physicians frequently observe a paradox. Some individuals develop complications at relatively modest glucose levels. Others remain stable even with higher readings. This suggests something important. Diabetes may not be a single uniform disease. It may represent a spectrum of metabolic states. To understand this, we must look deeper than blood sugar. Every cell in the human body carries a tiny electrical charge called the resting membrane potential. This electrical gradient determines how easily a cell activates and performs metabolic work. In simple terms, every cell behaves like a small biological battery. When this electrical state changes, metabolism changes. And when metabolism changes, glucose regulation also changes. Research exploring diet patterns rooted in Ayurvedic physiology revealed something fascinating. Different dietary patterns altered the electrical readiness of cells. Some stabilized cellular potentials near -70 millivolts. Others pushed them toward -90 millivolts. And some produced even deeper electrical polarization. In other words, diet itself changed cellular electricity. And when cellular electricity changes, metabolism changes. To understand this intuitively, imagine three vehicles: a Formula One race car, a heavy cargo truck, and a family car. If you fill all three with the same amount of fuel, will they behave the same way? Of course not. The race car burns fuel extremely fast, the truck conserves fuel and moves slowly, the family car operates somewhere in between. Human metabolism behaves in a similar way. Some people have fast reactive metabolic systems, others have slower systems that conserve energy and store fuel. Yet modern diabetes guidelines often apply the same glucose threshold to everyone. Interestingly, even major medical organizations recommend different glucose targets. The American Diabetes Association often recommends an HbA1c below 7% for many adults. Meanwhile, the American College of Physicians suggests a more moderate target between 7 and 8%. This may seem like disagreement, but it may actually reflect a deeper biological truth. Different bodies require different metabolic targets. Within the PRISM framework, Polyscientific Regenerative Integrative Systems Medicine, metabolism is viewed as a dynamic systems process. Different physiological states behave differently. Some metabolic systems resemble high-performance engines. Others behave like slow energy-conserving systems. Treating every patient with identical metabolic targets may overlook these fundamental differences. Understanding the body's metabolic engine becomes essential for personalized care. The future of diabetes care lies in precision metabolic understanding. By integrating physiology, biosignals, and systems biology, we can begin detecting metabolic imbalance long before diabetes fully develops. This approach moves medicine beyond treating numbers. It moves toward understanding the entire metabolic system. If three engines burn fuel differently, we would never blame the fuel alone. Yet in diabetes, we often blame only sugar. Perhaps the real question is not simply how much glucose enters the bloodstream. The real question is this: how does each person's metabolic engine handle that fuel? Answering that question may finally help the world move beyond the diabetes epidemic. Thank you.